underwater world is an exciting, adventurous place to visit. Welcome. You're entering a new world beneath the sea and the training that will enable you to enjoy it. Our purpose is to make it possible for scuba diving to be comfortable, easy, and safe for you. There are pool skills to learn, knowledge to learn, a required test to take, and 2 days at open water to put that all into practical use. The Rocky Mountain Aquatics were dedicated to do whatever it takes to help you become comfortable and safe. SCUBA means self-contained underwater breathing apparatus. It's a simple invention by Jacques Cousteau that makes it all possible, and you'll see just how simple that is when we take a piece of equipment apart and show you how it works in the Scuba divers and astronauts share one thing in common. They can hover in space, feeling weightless, not sinking or floating, but just suspended in whatever position or space you choose to be. Sea life is amazing. It's easy to become entranced by the life that you'll see underwater, and it's an experience you'll never forget. But it requires training in the classroom and in the pool and open water, which allows you then to become certified as an open water diver. That training you should consider to make it possible for you to dive in water down to depths of about 60 feet. If you want to go deeper than that, you really should get additional training. Textbooks are available. We recommend the Dennis Graver book, which is available through PDIC or through Amazon.com. On our webpage, SCUBALee.com or RockyMountainAquatics.com, we provide a study guide which summarizes all the important information and gives you additional resources. There's a DVD sequence which also covers all of the material necessary to be a comfortable, safe diver. You'll want to have a dive log to record your experiences, and a dive table to determine how long and how deep you should dive. There's another presentation which teaches you how to use dive tables. The risks of diving have to do with dealing with pressure, decompression illnesses, which is described in another presentation, and dealing with body air spaces, which we'll cover in this presentation a little bit later. You need training. You need to keep yourself refreshed in your scuba skills if you've been out of the water for a while. If you have seizures, if you're currently pregnant or have difficulty with lungs, you should reconsider doing diving training at this time. You want to minimize the risk and maximize your enjoyment. In making this transition from being a land animal to marine animal, we have to use equipment to make that transition possible. Mask, snorkel, and fins enable us to operate in the water. Your first gear that becomes you is a mask. You want it to fit properly. And you can test that by placing it on your face and breathing in. If you can hold it on by breathing in and not hear any air escaping into it, you probably have a good fit, but the best test is in the water. Until you've had some experience, it is not wise to go out and purchase a mask. Wait until after you have a little bit better feeling for what's going to work for you. The mask is an essential piece of safety equipment. You will often see people wearing their mask on their forehead. Do not do that. The mask should remain in place. Get in the habit of putting your mask on your face before you get in the water, leaving it on your face until after you are out of the water. That is an essential safety rule. Even though you see it broken often, don't break that rule. You need to know a little thing or two about the body and how it works. Most important to you often when going down into the water is equalizing the pressure in your ears. You have water pressure on one side of your eardrum and air pressure on the other side of your eardrum. And that pressure needs to be equal. You're breathing air when surrounded by water, and you need the air pressure inside you to be equal to the water pressure outside of you. Our equipment is designed in such a way that as long as you are breathing in and out, that pressure will be. We're breathing air, which is approximately 80% nitrogen and 20% oxygen. As we go down in the water, the pressure on that nitrogen changes nitrogen so that it takes on the properties of nitrous oxide, laughing gas. So the rule of diving on air is that we do not go below 100 feet. If we suffer from what's called nitrogen narcosis, we could make unwise decisions and be in serious trouble. We have other kinds of air mixtures to allow divers to go somewhat deeper than that. But as a certified diver, at the level that you begin with, 60 feet should be considered your maximum depth. Hyperventilation is often done by children in order to enable themselves to hold their breath longer. That also is a problem in snorkeling and diving because it interferes with your body's natural ability to regulate your breathing, and it can cause an effect called shallow water blackout, which is described in more detail in your reading. Water is more dense. You move through it more slowly. The major difference between air and water is air is compressible and water is not. If you were to take a balloon full of water down to 33 feet, 66 feet, or 99 feet, the volume of that balloon would not change. If you took a balloon full of air, as you take it down in the water, at 33 feet there is twice as much pressure, you'd have half the volume. At 66 feet there's 3 times as much pressure, you'd have a third of the volume. And at 99 feet you'd have 1/4 of the volume, 4 times as much pressure. This makes it important, since you're breathing compressed air, that you never come to the surface holding your breath. Atmospheric pressure is one of those things you'll learn about in your scuba class and in your reading material. That pressure difference creates something called squeeze. Mask squeeze, ear squeeze, and we learn to equalize those squeezes by getting an equal amount of air pressure. The biggest risk in diving is to come to the surface holding your breath. Always breathe in and out. Never hold your breath. The compressibility of air affects our breathing volume, our ear clearing, learn how to deal with mask squeeze, and even wetsuit compression. So the depth we go changes the amount of insulation we get out of our wetsuit. It's important to avoid pressure injuries. Your air will last differently depending upon the depth. For example, if you can breathe a certain amount of air for 1 hour at the surface, that same amount of air will only last you a half an hour at 33 feet and 1/4 of that time at 99 feet. Water takes heat out of our body 25 times faster than air, so we have to deal with that and compensate for that. It is possible to go into much colder environments with different kinds of wetsuits and different kinds of equipment. Things look closer and bigger underwater. Sound moves faster underwater. You cannot normally hear someone talk without specialized equipment, and you can't tell the direction of sounds.